Hello children, welcome back to my CK classes. Myself Puneet CK, and thank you for your overwhelming response to reach a small milestone of 100 subscribers. Keep supporting, subscribe and share our YouTube channel for more learning content. In our previous classes, we have learnt about AP and key concepts of AP, and today we will enter to the new topic comes under AP, which is very interesting. In my fourth session, we will discuss this concept. So let's get started, and today I'll start with a problematic situation. Please listen to the problem carefully. So here the problem is, a man wants to save money for his newborn child. He started with rupees 5,000 in first year, and he wants to increase constantly rupees 10,000 for every year. If the child reaches to an age of 24 years, what is the maximum amount he has been saved? So this was the question. Please note this question before you could proceed with this video. So later on, you will get the final conclusion to solve this problem at the end of the session. So why? So because when you break this problem by using some numerics or numerals, so you will get a result like this. Suppose if in the first year, if he saves 5,000, in the next year he only wants to save, because he is increasing by 10,000, it becomes 15,000. The next year it becomes 25,000. And if you keep writing like this, it reaches around 24 years. So if you keep counting like this, it is a terrible experience to add all the numbers to till 24 years. So, but in the maths, we can give a solution for this problem in an easy manner. So now let's give a solution for this problem in a mathematical way. The concept is helping me to give a solution for this problem is Sn, which means the sum of first n terms of an AP. Now let's learn what is sum of first n terms of AP. Here the sum of first n terms of an AP represented by the sign Sn. Suppose let an AP be A1, A2, A3, A4 and so on. So now I want to write simply if I write S1. The meaning of S1 is sum of first term. S1 is equal to A1 is also equal to A. It's an important one, just keep in your mind. S1 is equal to A1 is equal to A. If I write S2, that is sum of first two terms. Here first two terms are A1 and A2. You could write it as A1 plus A2. Same thing if I write S3. S3 means what? It's very simple. Sum of first three terms, that is A1 plus A2 plus A3. If you want again same thing for S4, I think you can predict it right now. What is S4 now? That is simple. A1 plus A2 plus A3 plus A4. So if I extend this knowledge, suppose the terms are containing still n terms. We can say the ABB up to n3 up to n terms. So now if I write Sn, it's very easy to write. Sn is equal to A1 plus A2 plus A3 plus A4 plus etc. up to nth term. So this is called sum of first n terms of an AP. If A1, A2, A3 are in the AP. Now let's take an AP. The AP contains 10, 5, 0, minus 5, minus 10, and I need to find S3 for this. As I mentioned, the meaning of S3 is sum of first three terms. So now, what you have to do, you just call 10 as A1 and S as A2 and 0 as A3. Now since you need S3, S3 can be written as A1 plus A2 plus A3. Now what A1 is there is now? A1 is 10 plus A2 is 5 plus A3 is 0. When you add up them, the answer is 15. Therefore, the sum of first three terms of this AP is 15. Now, let us derive a formula for sum of first n terms of an AP. Now, let us consider an AP. Sn is equal to A1 plus A2 plus A3 plus etc. up to An, the sum of first n terms of an AP. Now, as you know, what is A1 stand and A2 and A3. Let me write it. Sn is equal to A1 is A, A2 is A plus D, A3 is A plus 2D plus etc. An means, as you know, the nth term of an AP is A plus n minus 1 into D. So now A plus D is the second term, A plus 2D is a third term, and An is a plus n minus 1 into D. Now for my reference, I'm just in the sense An is the last term, A plus n minus 1 into D I'll assume as L. Now I'll replace this expression with L. Sn is equal to A plus D, A plus 2D plus etc. A plus n minus 1 instead of A plus n minus 1 into D, I'm writing L. I'll still modify. Just have a look. Sn is equal to A plus D, A plus 2D plus etc. Imagine the last term is L. What is the preceding term of L? You need to subtract D from L. It becomes L minus D. Similarly, this becomes L minus 2D. So now, let me call this expression as equation 1. Now, I'll write Sn once again by reversing the digits. So now what I should write? This I'm reversing this one. So when you reverse it, it becomes L plus L minus D plus L minus 2D plus etc. Instead of L minus D, what should I write here? A plus 2D plus A minus D at last plus A I'm writing. This status I reversed it. I'll call this is equation 2. Now add 1 and 2. If I add 1 and 2, what I am going to get now? Sn plus Sn. Just underline this first. Sn plus Sn, it's 2Sn A plus L. Let's add these two terms. Similarly, these two. Similarly, these two. This and this. So A plus L plus AC. I am adding these two terms here. Plus D and minus D cancel each other. What is going to remain now? A plus L. Here also plus 2D minus 2D cancel. What remains? A plus L. Similarly here, minus 2D plus 2D get cancelled. You will get L plus A, or you could write it as what? A plus L again plus A plus L plus A plus L. In all the cases, you will get A plus remains when you simplified it. So here I will give a trick. Suppose you have 5 6 times. 5 plus 5 plus 5 plus 5 plus 5. Suppose if you have 5 6 times, so what is the sum if you ask? You just add them 5 plus 5, 10, 15, 20, 25 and 30. So instead of that one, you have a trick now, you just count them. 1, 2, 3, 4, 5, 6. There will be 6 5s are there. Into 5 you do, 6 5s are 30. The sum you are going to get. I'll use the same trick for this one. Here, I don't know how many terms are there, since etc. there is here. I'll assume there are n number of terms. So I can write it as 2Sn is equal to n times A plus L. It's very simple trick. Just I use the same trick. What I used here, the same thing. Since there are n terms, I am writing as n times A plus L. Now transpose 2 to this side, I cross multiply. Therefore, Sn is equal to n by 2 times A plus L. So this is very important one. So this is a formula to find sum of n terms of an AP. So now this is very important thing one. So this is a formula to find sum of first n terms of an AP if you know the last term. Just I'm marking here. So this formula you must recall often. So Sn is equal to n by 2 times a plus l, where l is the last term, a is the first term, and n is the number of terms, and Sn is a sum of first n terms. Now Sn is equal to n by 2 times a plus l. As you know, a plus, instead of l, what I should assume? Instead of l, I have assumed as a plus n minus 1 into d and put it back. L is equal to, you put it as a plus n minus 1 into d. Now simplify here. So n by 2 a, that is a plus a. A plus a means 2a plus n minus 1 into d. It's a final derived formula for an AP. Therefore, Sn is equal to n by 2 times 2a plus n minus 1 into d. It's a finalized formula to find the sum of first n terms of an AP. So I'm telling again, what is Sn? The Sn is the sum of first n terms of an AP is equal to n by 2 times 2a plus n minus 1 into d. Now, the concept of an and Sn are totally different in the keynote 1. So, most of our children will compare an with Sn and Sn with an. The kid is stuff in your mind, don't forget it. So, they are totally different. They are two different unique nature. An is just a term of a sequence. Sn is a sum of first sum n terms of the sequence. So, don't compare an with Sn and Sn with an. And secondly, this is a relation between Sn and preceding term of Sn, which means Sn minus 1 will always gives you an. So this is a fundamental relation you must know to solve some different types of problems. So now let us take one question from this concept Sn. So here question goes like this. In a given AP, find S20, which means you need to find sum of first 20 terms. So the given AP is here, the 10, 15, 20 and etc. I'll collect some data for this. So as you know, A is equal to D, so A is equal to 10 and D is equal to 15 minus 10, that is 5. And still you want to find S20, therefore N is equal to 20 and you have to calculate S20. The solution for this is very simple. Sn is equal to n by 2 times 2a plus n minus 1 into d. This is a formula I'm using. There was one more formula, but last term has not been given. You can't use for this one. So now let me substitute all the values what I got into here. That is n is equal to 20. That is S20 is equal to 20 by 2 times 2 into a. A equals 10 here. Plus n is equal to 20 minus 1 into d is equal to 5 there. At last, so 20 over 10, so the 20 over 2 is 10, the 2 tens are, it's 20 plus 20 minus 1 is 19 times 5, so 10, 20 plus 19 5s are, it's 95, so 10 times 20 plus 95, it's 115, at last the answer is 1150. Therefore, sum of first 20 terms of the sequence is so 1150. So now let us find a solution for the problem which I generated in the beginning of the session, a problem of man. So the problem, when you break that problem into a sequence, the sequence is going to generate like this. For first year, he is going to save money of 5,000 rupees. In the second year, so he is going to save money of, because 10,000 is putting more, it becomes 15,000. On the third year, it will be at 25,000. So it can keep continuous still 24 years. So now, so I want to check whether the given sequence is an AP or not first. Let's do it. So first I'll write A is equal to 5,000, no problem in that. So now let's find common difference. D is equal to, as you know, A2 minus A1 is equal to A3 minus A2. That is, A2 is how much there is now? 15,000 minus 5,000. You will get 10,000 as a common difference. Similarly, let me find A3. A3 is 25,000 minus 15,000 is equal to 10,000. So still the common difference is same. The given sequence is an AP. So you need to find up to 24 years. Let me assume n is equal to 24. Let me calculate S24. If I find S24, we'll get the whole sum. So let's do it by using a solution. So what is the solution for this problem? That will be the solution. Sn is equal to n by 2 times 2a plus n minus 1 into d. Let's put the values now. S24, that is 24 by 2 times 2 times a is equal to 5,000 plus n minus 1, that is 24 minus 1 into common difference is 10,000. So now, 24 over 2, you will get 12 here. So 5,000 double it, 5,000 you double it, you will get 10,000 here. Plus 24 minus 1 is 23 into 10,000. So now simplify this. 10,000 I'm writing as it is. 23 into 10,000 will get 2,30,000. So 2,30,000 plus 1,000, so 10,000, that is 12 into 2,40,000. So once you multiply 2 lakh with the 12, so let me multiply 24 into 12. For 2s are 8, 2 2s are 4, 4 1s are 4, 4 plus 4 8, 2 1s are 2. So at last 288. So 4 zeros are there, I'll put it here. So you can, at the end of 24 years, the man is going to save 28,80,000 rupees. And so there was a confusion, so whether maths is helping us or not. So now at the end of every lesson, I am going to tell you all where these maths is useful, or what these lessons are useful in day-to-day life. Just now AP was a concept under mathematics. So now AP is helping us to calculate. So it will help us to calculate easily. So imagine if you write all the terms here up to 24 terms and you just keep on adding. It takes a long time. But if you use a formula, you get an answer within a minute or 1.5 minutes. So now let us recall what we have learned today. So now we started our journey with respect to Sn. Now we are in the ending position right now. Sn is equal to n by 2 times 2a plus n minus 1 into d. It's a fundamental formula for Sn. It is applicable to almost all the problems. Sn is equal to n by 2 times a plus l. So this formula will be applicable if you know the last term of an AP. If you have any doubt related to my teaching content, you can contact me via WhatsApp. These two are my phone numbers. You can record it and you can ask me the questions via WhatsApp, or you can put comments on the comment section. Even I will try to reply in comment sections too. Thank you.